I'm CK. Tonight we've got a little more complicated kit, and it's not just to put together, have a little fun with, and put away. This is a signal generator kit that I picked up from Amazon. It generates electronic signals, waves, various waveforms, various trigger functions that as you go on in your electronics career, you'll find very useful. And if you follow this channel for musical instruments in the eurorack vein, you can generate signals with this to test control voltage, to substitute for an LFO, and a lot of other things you can do to not just diagnose your rack setup, but actually give it some interesting musical input. So we'll put this together. It's going to be a complicated build, or a longer than usual build, and I'll show you how it works. And I hope you enjoy the video. Let's explore what's in the bag. Function generator JYE kit. Let's look inside the bubble wrap first. Looks like, oh, it comes with its own power supply, which is nice. It's 110, 240, 50, 60 hertz, so it's universal. Puts out 15 volts DC at 1 amp. So this is a good little power supply to have whatever you're doing later on, whether you use this kit every day or not. All kinds of things in the bag. We've got a quick use guide, so that's good. So once you get it put together, you can see how to use it. Here's the circuit board. Oh, it's got a bunch of surface mount components already mounted on it. And that's interesting. There's a whole bunch of pads that don't have components on them. They're not jumpered. They just don't have components. And then I'm looking, and the surface mount soldering is not all that great. There's one resistor. Where was it? This cap is up a little bit. There was another resistor I saw that was way up. So just double check those. I think they're all good. 20 megahertz clock chip. Couple of processors, I don't know what they are. I cannot read the part number on them. So, lots of surface mount. But it's already done, so you don't have to worry about it. Here are the two panels. Here's the front panel with all the buttons. Here's a back plate for it. Output probe. And here I'm going to assume is the display. Yep. Here's the display. I have a pin header that goes in there. And again, there's a controller chip missing. There are two caps that aren't installed, and another cap over here that's not installed. I don't know why. And there are two ICs under potting material under there, the LCD driver. Nothing else in there. So since they've done all the surface mount for us, what we will be doing is putting some big electrolytic caps on, putting a USB connector on, all the switches, BNC connector, and all the switch caps, of course, and one pot. Or is there more than one pot? Oh no! Oh, it's a clicky. It's a continuous switch. you know, like on your car radio tuning knob or whatever, not a potentiometer. So that's what's there, and I don't see a build guide. However, we really don't need one, but I will look to see if there is one. Perhaps it's mentioned in here. Yes. Go to www.jyetech.com for detailed and up-to-date documents. So that's where we will find a build guide, I'm sure. Oh no, here it is. Here's the assembly guide. It's on the back. All easy. So let me get the soldering iron heated up and we'll put this thing together. Okay, first thing they'd like us to do is put all the parts on the back. And this, where the componentry is the back. I'm going to put some pin headers in here. I'm not really sure why. But we'll do that. Have to get a new piece of solder. And as usual, I'll solder one pin on each of them and pick it up. As you can see, they're not level, they're not flat to the board, but all I do is put my thumb on it, heat up the solder ball, and it flattens right on out. The other one is actually flat, so that's good. Now I'll just do the rest of these pins. Get the power connector, and it will go right over here. Now it's interesting, it's got two holes here that you could put a pin header on instead of the power connector if you wanted. But we'll use the power connector because they were generous enough to give us a power supply with this kit. And we'll put the USB connector on also. Where is it? Little guy. Got a bunch of little pins on it. It goes, where does it go? It goes over here. This can be a little tricky to do. These little, oh, what the heck? Sorry, the top camera didn't come on. Now I'm double checking the side camera to make sure it's on. Yes, it is. I'm sorry guys, top camera didn't come on. I'm going to pause for a bit so I can synchronize the cameras. Okay, now we've got both cameras running. So these little USB connectors, you have to be careful because these pins are really, really close together. So first I'm going to solder one of the support legs so things will not move around on me. And I'll solder this other one. Make sure things are flat. Things are flat. Now, go very carefully, just use a little bit of solder, and that bled over. What we're going to do is just take our little solder pump, heat up this blob here, and it pulled out the blob, and you can see that there's still enough solder, there's still plenty of solder because this is through-hole plated, that there's a fine connection there. We don't have to do anything further on that. And now we'll do the 100 microfarad and the 47 microfarad cap, or 470 microfarad cap. So the 470 goes up here, long lead to the positive hole. The 100 goes, oh, we've got 3 of them. Oh, we've got 2 470s. I'm sorry, I didn't look at this. 2 470s go here. And we've got 300 microfarad caps that go here. And that's on. Now we're going to put the power button. Power goes here, and it is polarized. The side with the 2 dips, as the instructions say, goes there. And as always, when you're working on a board that has surface mount components already installed, be very careful you don't touch them with your soldering iron, because they could come loose, they could get overheated. Lots of challenges when you're working around surface mount, so just keep good control of your soldering iron. Now we'll put the rotary switch on. Which has 3 pins on one side, 2 pins on the other, so you would have to try and get that wrong. Wouldn't be easy. I'm looking for other scraps of solder I can use, because I don't like to cut a new piece if I don't have to, because as you can imagine, if you look at my channel, I go through a lot of solder. So I try to use every bit I can. And I'm using my thicker solder for these support legs. Now back to the thinner for the data connections, the electronic connection that transmits the little pulses when the switch rotates. And now, as we look, except for the BNC connector, which we're going to do a little bit later, we are going to put all the switches on. So let's put one on in real time. And I believe, I don't know whether these, okay. So for all switches, the side with the 2 dips must face the end where the power connector locates, in other words here. So 2 dips to the left. And we'll see how this goes. Again, we can't set it flat, so we've got to rest it on our finger. Wrong solder. Where did I just put that little piece of solder? There it is. And we'll just do one leg again. Oops, and that came completely out because I didn't wait for the solder to dry or cool because I was being impatient. So let's just heat that solder up, get that back through again. It's still a little high, so I'm going to press on the button. There. You might even heard it click. So what I'm going to do is I'm going to do that for each switch. I'm not going to solder all the legs at first. I'm just going to put each switch on with one leg done, and then I'll go back through like assembly line and get all the other legs soldered in place. So because I'm going to be doing that, not much to talk about. We've already talked about the important bits on switches, so I will put the video in fast playback and not have any commentary, and you can enjoy watching the switches go on the board real fast. And that's all, the connections all soldered up. What I'm going to do now is grab my little index card, and I'm going to look at each connection, make sure, number one, that I soldered everything, because when you have this many you might miss some. Second, I'm going to make sure nothing is bridged and all the solder connections look good. Let's see what the magic instruction sheet says to do next. Now we're going to mount the panels. All right, we need to do that. Okay, now we're going to put the panels together because all the soldering on the board has been done, but first we have to prep the BNC connector. So this is a little tricky, can be a little tricky. So the BNC connector is going to go here, but we have to drop a lead. I have to get a resistor lead from another project, or you can get a thin piece of wire. We have to drop that from the washer here down to this connection here. So what we're going to do is we're going to grab the washer, the lock washer with the wing on it. We're going to cut the wing off. And now we're going to find a resistor lead. I usually have a pile of them. There's one. There's a good long one. And I do want to verify the length to make sure if I solder this in, it will actually go through, and it will. Now I'm going to bend it just a little bit, bend like a 1/8 of an inch, 3 millimeters, something like that. And I'm going to be soldering it on here, but I don't want to just try and manipulate 3 things at a time. So I'm going to make a pool of solder on this washer, like so. And then I'm going to take my needle nose, because if I don't, I'm going to burn myself again. Not that I mind, but I'm actually trying to show you the right way to do this. And then we'll heat that solder up again. And put the wire in it like that. And as you can see, the solder flowed over the wire, and now it's fully connected. And of course it's still hot, so theoretically it would burn me, but since I have burnt my fingers so many times over the last 50-some years of building electronics, I can't feel much pain in my fingertips, I will admit that. So now we're going to take the plastic off this. Oh, this isn't quite flat. That's interesting. Now we put the BNC connector there. And we're going to put the washer we just built up there. And then get the other washer. Oops, and bend the wire I just did. Put the other washer and then the nut. And now don't put the nut too tight yet, because we're going to rotate the lock washer around. So it'll go in that hole in the circuit board. And I'll go ahead and test that quickly. It's actually a slot, so you can have a lot of margin for error, so you don't have to worry about it. You don't have to stress about trying to get it lined up so it'll be exactly in a circuit board hole. I'm going to tighten this nut up. So that is all the things we're going to be doing with the soldering iron. So I'm going to turn the soldering iron off. Now the next thing, obviously we have to put the switch caps, button caps on. So I'm going to do that right now, and I'll do that again in fast motion. They're square, they're rectangular, so you have to get them just right. All the caps are on. Now we're going to put some standoffs. I'm not going to use any tools to tighten those, I'll just tighten them finger tight. And it does not matter which end is the threaded end and which end is the captive end. Because again, they're both the same size. Now, we're going to drop the front panel on, and before we do that, we're going to take the film off the display, the shipping film, because there is a plastic, piece of clear plastic there, and I got some fingerprints on the back of it, so I'm going to wipe that all off before I put the things together. Now I'm going to drop this in, and again, I want to make sure everything lines up. That wire lines up. Oh, look at that. The adjustment knob has to go on after the panel is on. The buttons don't. The button caps don't, but the potentiometer I mean, not potentiometer, the rotary switch does. Now, you may want to get your pokey thing out and just move the buttons around a little bit. So everything will drop on. Let me see who's holding things up here. Number 8, number 3. There we go. Now it's all down. And as you may be able to see, well, not really, there we go. The center lead of the BNC connector is now connected to the board, and that piece of wire for the ground is through the slot, and I'll solder that in a little bit. I was wrong. I turned my soldering iron back on because we do have to solder that. And here's a little piece of paper I missed. Now, of course, before we put the bottom panel on, we'll solder this BNC connector. I'm going to let that heat up a little bit so it really takes solder and we get a great connection. There we go. Make sure it's bled into there. Yes. Now we can do the little piece of wire we tacked on. And I'll trim the excess off that. Now we can put the rear panel on. And we'll hook up the BNC connector. Check all the buttons to make sure they work and don't rub against the side of the panel holes too much. No, everything seems fine. So that's it, ready to power up. So I'll get the oscilloscope warmed up and connected, and we'll see what this thing does. Really kind of irritating. But in any event, we're ready to power on. We've got the scope up to see what it does. And now I've got the scope hooked up here to the BNC output. And now we'll turn it on, make sure it powers up first, of course. Powers up just fine. And that should be a 1000 hertz sine wave at 5 volts. And if we look on the scope, alright, so that's a pretty steady sine wave. Let's see what we can do with it. Greater than 1000. Let's see if I turn this. I'm turning it up. And you can see, I want to see if I can do this even more. I know I can do this a different way. Set frequency, you hit the FT button, and then we'll put this up at 2000 hertz. It's 2000 hertz. As you can see, it's closer. Let's do it again. We'll go up to 5000 hertz. And now it's a very tight plan, so that's good. So that's all constant waveforms, and we can set the amplitude, offset, and incremental, but we don't care about that right now. We'll do frequency sweeping mode now. Okay, now we've got sweep going. And we adjust to select parameters. So this starts at 1000 and stops at 50,000. So I'm going to change that to, I'm going to stop it at 5,000. And now you can see it's going, incrementing up to 5,000. There's 1,000. Now it's going up to 5. You can see because, of course, the pulses are getting shorter. Let's do another mode. Let's do servo pause. And I forget how I did this. There we go. Servo pause. And what does this do? Pulse width. We'll do a slightly shorter pulse width. That's the pulse we're getting right now. Oh, there we go. Now we can do it. Now I'm shortening the pulse width. Now I'm going to make it much wider. Yep, it maxes out at 2,000 microseconds. Okay, so that's what the issue was. Now we can set the amplitude. That's at 5 volts right now. We'll take it down. As you can see, it's going back down. It's down at 3 volts. 2.5 volts. See what else we can do. Change the amplitude, all that. I'm going to go hit that, and we restored it back to what it was initially. Now I'm going to go back to continuous wave, and I'm going to change the waveform. Here's a square wave, the triangle wave, ramp wave, step, step down, and then user. You can set that to whatever you want. And then we're back to sine. So that's what it does. You can send these signals into anything. You can send them into an audio circuit at a point where you think it might be bad, or before you think it might be bad, and then use your scope past the point where you think it's bad and see if you're getting the same signal out that you sent in. If you want, you can use this as a low frequency oscillator for a music system or other. There's lots of things you can do with signal generator, function generator, and this one is inexpensive. Again, it's somewhere between $40 and $60. I forget exactly how much I paid for it, but I'll put a link in the description. So that's what this thing does, and again, it's pretty easy build since most of the hard parts were already surface mount soldered. So there wasn't anything to do but put the interface buttons and so on. But a very useful device when you're done, something you should have in your workshop. Hope you enjoyed the video.